All right. So this is chapter 6, practice B, problem number 3. And it says a zero point 0.4 kilogram soccer ball approaches a player horizontally with a velocity of 18 meters per second north. The player strikes the ball and causes it to move in the opposite direction with a velocity of 22 meters per second. What impulse was delivered to the ball by the player? Um, so I have this picture here. As you can see, initially the ball is heading 18 meters per second north, this direction, and we're going to call that the negative direction. And then after the player kicks it, it moves south at 22 meters per second, and we'll call that the positive direction. Um, so we will look over here where there's a list of formulas. To calculate impulse, we need force times delta t. That also happens to be the equation for delta momentum, as listed on the AP Calculus, not AP Calculus, AP Physics sheet. So that's the given equation. So what we're really trying to find is delta p. Since we don't have time, we can't express any answers in Newton seconds. So we're going to have to use change in momentum. And here it says momentum is mass times velocity. We also have the equation for delta velocity, which we'll need later. And we have force equals mass times acceleration. So we look here, we can calculate delta velocity by subtracting 22 meters per second minus negative 18, which ends up being positive. So it becomes positive 40 meters per second. And that's a change in velocity after the player kicks it. Now that we have that, we can do some algebra, these equations. So we start off with delta P equals F delta T. F equals ma, therefore we can substitute mass times acceleration into this, as I did here. Once we have that, we can also substitute acceleration. Acceleration is delta v over delta t. If we sub that in, the t over here cancels out with the t in acceleration, leaving us with delta p equals mass times delta v. And I may have said a bunch of letters. If you don't understand, you can always just spend some time looking at the algebra of this. We're going to move on. We are going to plug in numbers. So this is the equation that is going to give us our answer. We can plug in mass, which is 0.4. kilograms. And we multiply that by the change in velocity, which is 40 meters per second. And we do that, it comes out as 16. Whoops, what an tarnation. Yeah, it comes out as 16. And we need units. Of course, that's kilograms multiplied by meters per second. So it comes out as kilogram meters per second. We also need a direction, which is south, since the ball is moving opposite of north. And this is the answer right here. Notice that it's actually measured in units for momentum, not Newton seconds, but that's okay because that's what the textbook says. The end.